If you're an incoming senior high school student or college freshman, this algebra review will equip you with the knowledge you need to succeed. Feel free to visit the timestamps for this video. For Set 1, we'll tackle Introduction to Algebra. For Set 2, we'll talk about functions. For Set 3, we'll have quadratics and polynomials. Set 4, trigonometry, and Set 5, pre-calculus. The sixth set, geometry, is a combination of these topics and is coming soon. So you may be curious, what are these dates listed on the timestamps? So the full videos of these sets will be uploaded on the dates indicated here. This video is a free version of the algebra videos sets 1 to 5, consisting of 40 items. Next week, you'll also have 10 items of the geometry challenge set for free on YouTube. If you enjoy the content of these videos, I highly recommend availing the full course. For only 199 pesos, gain exclusive access to 115 additional items for algebra and geometry, as well as another 35 items for the Google Forms mock test, which you can access through Google Classroom. On top of that, you'll also get slides and cheat sheets that you can download and print. If this sounds like a good deal to you, check out the description for the registration form. So for a bit of a background, I've been making these types of presentations since 2018, all the way back in junior high school. Just recently, in March this year, I was a student tutor under Project Reach of DOST-SUI, particularly in Calabarzon. So I tutored through Zoom on the topic of geometry. So for Set 1, Algebra Foundations, we have the order of operations, simplifying algebraic expressions, solving linear equations, single variable word problems, and the concept of factoring. So let's go over some notes. First of all, we have to follow the order of operations PEMDAS, which is parentheses and exponents, followed by multiplication and division, and then addition and subtraction. Next, we have simplifying algebraic expressions. We can add like terms that have the same variable. For the distributive property, we can distribute a coefficient to each term it is being multiplied to. For the negative sign, we have addition and subtraction. So adding a negative number is basically the same as subtracting it. So subtracting a negative number is the same as adding it. So for multiplication, two negative numbers multiplied to each other will yield a positive product, like negative 2 times negative 3 is equal to positive 6. However, if one is negative and one is positive, we have negative 2 times positive 3 is equal to negative 6. And lastly, if the negative sign is included inside the operation, like the square of negative 3, we have positive 9. But if it is outside, like this, the negative square of 3, then we have negative 9. So these are the things we need to keep in mind when doing algebraic expressions. So let's start with some examples. So for number 1, we have the square of negative 3, which is 9. And then 4 times negative 2 is negative 8. So 9 minus 8 is going to be 1. For the next item, we have 3 times 2x minus 4 plus 5. So 2x minus 4 is in parentheses, so we're going to apply the distributive property here. 3 times 2x is 6x, and 3 times negative 4 is negative 12, plus 5x. Adding like terms, we have the final answer, 11x minus 12. So number 3, write an equation for 3 times the number increased by 4 is 19. So we have a number, which is our variable, it can change, multiplied by 3. And then increased by 4 is equal to 19. Now, for number 4, to solve for x, we need to add -7 on both sides. So the reason we're doing that is we want to get x only. So we're going to subtract 7 from both sides. So that's going to be 2x is equal to 12. You could also do transposition, where you just move this to the other side and put a negative sign. Now the next thing we have to do is 2x is equal to 12. There is a 2 beside x, so we need to divide both sides by 2. So we can see that x is equal to 6. To double check our answer, we can put it back here. So 2 times 6 is 12, and 12 plus 7 is 19. So similarly, for number 5, let's solve for x. When you see something like this, it's generally best to put all of the x's on one side. So going to move this here. 5x minus 2x is 3x equals the other side. So we're going to move -3 to the other side. It's going to become +3. +3 plus 9 is going to be 12. So dividing both sides by 3, you have x is equal to 4. So number 6, the sum of two consecutive integers is 45. What are those integers? So when we say consecutive, it means that their difference is 1. So there's going to be the first integer as x, and then the second integer is x plus 1. We know that their sum is 45. So from here, we can solve it. Transpose 1 to the other side, and then combine like terms. So that's going to be 2x is equal to 44. Dividing both sides by 2, we have x is equal to 22. So since the question is asking what are those integers, we also need to solve for x plus 1. So x plus 1 is 23. So the final answer is 22 and 23. So now that we've learned about linear expressions and equations, let's see what happens when we multiply two linear factors. So in multiplying two linear factors, we can apply the FOIL method, which is an extension of the distributive property. We go x times x for first, x times -3 for the outer, 1 times x for the inner, and 1 times -3 for last. Upon combining like terms, we're going to have x squared minus 2x minus 3. Now we can factor this quadratic expression back into their two linear factors. So you can see here that there is a sum and a product. So this part here, for the outer and the inner, this represents the sum. So the coefficient of the middle part is the sum. So -2 is the sum of 1 and -3. As for the product, the constant at the end is the product of the two numbers. So -3 is the product of 1 and -3. So basically, we can go forward and backward if we know the process of this. So for number 7, let's factor x squared minus x minus 6. So we know that we have two linear factors. Now, we know that the variable is x. And then we have the product of -6. Recall from earlier that a negative product has two factors, one that is positive and one that is negative. So now we just need to figure out what to put in here. 6 can be written as 1 times 6 or 2 times 3. Since we're trying to find a sum of -1, we need to have numbers that are close together. So that's going to be 2 and 3. Now we need to figure out which one is positive and which one is negative. Since this is negative, then the bigger number must become minus. And then the the smaller number must become positive. So we have this. On the same topic, when we are reversing it, we need to make sure to apply the signs correctly. So a lot of students, when they see this, they go, x is equal to only 6. So this is not correct. So when you apply this in a full solution, you need to write the square root of x squared is equal to positive negative square root of 36. Or simply, x is equal to positive negative 6. This is because squaring this is also the same as squaring this. So you're going to see more of that in the next set, which is set 2, the functions, graphs, and systems. So for this set, we'll be graphing linear functions, exploring systems of equations in 2 variables, evaluating functions, domain and range, and then interpreting function behavior. So here are some notes to consider. So for the equation of the line, most of us use y is equal to mx plus b. So if we have this Cartesian coordinate system, we usually start the line by drawing at 0b, or the y-intercept. And then we find the slope of it, the slope of the line, like rise over run. So it's going to be rise over run. And then we connect the points to draw it. So this is the most common method. We also have the slope point form, where we focus on m, which is the slope. So m is equal to rise over run, which is y minus y sub 0 over x minus x sub 0. Lastly, we also have the intercepts form, where we have the x-intercept and the y-intercept. For example, when the x-intercept is at 3 and the y-intercept is at 2, we can just write 1, 2, 3, and then 1, 2, and then we connect the line. So these are the 3 ways on how we can graph a line. So let's start with an easy example. Let's sketch y is equal to negative x plus 2. So this plus 2, sorry. So this plus 2 is going to be our y-intercept. So on a Cartesian coordinate system, we can count 2 units up. And then our slope is going to be negative 1. So that's going to be negative 1 rise, and then positive 1 of run. So from here, we can now connect. Alright, so that's all for number 9. So for number 10, let's identify the slope and the y-intercept. So it's not obvious here since it's not in the same format as earlier. But what you can do is move everything you don't need onto the other side. So we have y move to the other side. So you basically want y to be separated from everything else. And then for 7, you just move it to the other side. And then copy everything else. So we can see the slope is 3 and the y-intercept is -7. For number 11, it's time to solve the systems of equations. So there's two ways to do this. You can do this by adding the equations or by substituting them. So for this example, we already have y, one is positive and one is negative. So it's easy for us to just add them. So x plus 2x is going to be 3x. This is going to become 0. And then 5 plus 4 is going to become 9. Dividing both sides by 3, we have x is equal to 3. Now we know that x plus y is equal to 5, right? So if we know that x is equal to 3, we can rewrite this as 3 plus y is equal to 5. So we have y is equal to 2. So the solution for the system of equation is 2, 3, 2. So for number 12 and 13, let's evaluate the function f of x is equal to x squared with the value of x being -3. So what you're going to do is just put -3 inside x. Now, a common mistake that people do when they see this is they just do it like this, and then they have it as -9. So this is wrong. Remember that you need to follow the grouping symbol when you substitute in a function. So you have to put a parenthesis around the value of x. So the correct answer of this is actually going to be +9. So for number 13, we also evaluate it as f of -3. What we have to do is just multiply -2 by -3. So remember, negative times negative becomes positive. So that's going to be 6 plus 5. And then we have 11. So the final answer for number 13 is 11. For number 14 and 15, we have these functions. So this is a piecewise function. For those who don't know, it is a function that is split in different parts based on the value of x. So just a quick idea on what this is supposed to look like. So if x is less than 0, it's going to be from 2x plus 1. So plus 1 here. And then 2x, slope is going up and down in this direction. And for the other side, x squared, if x is equal to or greater than 0, it's going to become like this. So if you see something like this on your test paper, this hollow point means that it is not included. If you see a filled point, then that means it is included. So you usually see these based on these signs. So if it is greater than or equal to, you use this one. If it is less than with no equal, we need to use this one. So we have to evaluate f is equal, f of -2 and f of 3. So what we're looking for is f of -2 somewhere here. And f of 3 is on this side, somewhere here. So for -2, we'll be using this function. And for +3, we'll be using this function. So just like earlier, just substitute your values in x and solve. So that yields -3 for the first one and positive 9 for the second one. For number 15, we have what is the domain of 1 over x minus 2. So recall that the domain is the values of x that are allowed, while the range is the values of y that are allowed. So we need to check here what could be the restriction for this domain. We know that we cannot divide by 0, right? So that means the denominator, x minus 2, cannot be 0. So now it is time to answer this. It's a bit easy. We have x cannot be positive 2 after we transpose this to the other side. So the domain of this is x cannot be negative 2. There are other ways to write this, such as this one. In set builder notation, x such that x is a part of the real numbers and x cannot be equal to 2. Another way to write this is with interval notation. So starting from negative infinity all the way to 2, and then 2 all the way to positive infinity. We have to use the parentheses or the round brackets to indicate that 2 is not included. So here are the different ways to write the answer for number 15. So for the last item in set number 2, a food stall sells rice bowls at 80 pesos each and drinks at 20 pesos each. A customer spends exactly 760 pesos on a total of 14 items. How many of each did the customer buy? So this one is a bit tricky, but let's see. We know that there is information on the price, and there is information on the items. So what we need to do is make a system of equations that uses both of these. So let's start with the items. We know that there are a total of 14 items. So let's have 14. So there are bowls and drinks. So I'm going to use the variables b and d. So b and d is equal to 14. So now that we have this first equation, let's have the other one. So we know that a bowl is 80 pesos each. So 80b represents the price of the bowl plus 20 pesos each for the drinks. We know that the total is going to be 760 pesos. So now let's proceed. Now to do this system of equations, we need to multiply all of this by a number that can eliminate the variables. So one way to do this is to multiply this by 20. So we have 20b, 20d, and 280. Since our goal is to eliminate this one, then we have to make this one negative. So when we multiply this by negative 1, make sure to negate everything else as well to keep it equal. Or you can simply write multiply this by 20 and then subtract. So you can also write it like this. 80 minus 20 is 60b. 760 minus 280 is going to be 400. 80. And then this is going to be 0. So now this is eliminated. We have 60b is equal to 480. So divide both sides by 60 and you will have b is equal to 8. So we know that there are 8 bowls. So now we just have to figure out what the other items are. So the other items are all drinks. So 8 plus something is equal to 14. That means there are 6 drinks. So 8 bowls plus 6 drinks makes up the 14 items. So to answer the question, how many of each did the customer buy? They bought 8 bowls and 6 drinks. For set 3, we'll tackle quadratics and polynomials, including special products, completing the square, quadratic determinants, graphing quadratic functions, and polynomial division. If you like what you're seeing so far, check out the description for access to the full course. So, a bit of notes before we continue. Here are some special products we will be using in our video. So, the special products first is the perfect square trinomial. When you square something, like when you square a linear factor like x minus 2, instead of doing the FOIL method on itself, x minus 2 times x minus 2, you can just follow this special product. So you're going to square the first term, x squared, square the last term, which is 4, and then multiply the two terms together times 2. So that's going to be 2x times 2, 4. So for the next special product, we have conjugates, or the difference of two squares. So for conjugates, you have x plus y and x minus y. For example, x plus 3, x minus 3. You can rewrite this as x squared minus 9. So if you're curious what happens, you can try doing the FOIL method on it. And you'll see that there will be some terms that cancel out. So the only thing you'll be needing is d. So for number 17 and 18, let's proceed. So there are two ways we can solve for x here. The first way is to have x squared is equal to 9. And then we have x is equal to positive or negative 3. Again, it's important to consider both the positive and the negative roots when we are applying the square root. So another way we can do this is to factor this. So x squared is a perfect square, and 9 is also a perfect square. So we have x and 9 being broken down into two threes. So we have one positive and one negative. When we have something like this, we can equate each of it to 0. So x plus 3 is equal to 0 and x minus 3 is equal to 0. So regardless of which one you put here, you're always going to have one positive and one negative. So you're also going to have the same answer as this one. So for number 18, let's solve for x. So in solving for x, we can see that this is not a perfect square trinomial, but this does follow x squared plus bx plus c, the formula we showed earlier. So in doing this, we have to look for factors here. So we know that 3 is going to be 1 times 3. And this is the only set of factors that is convenient. And luckily for us, we have 1 plus 3 is equal to 4. So we have x plus 1 and x plus 3. Now in solving for x, we can equate f of x to 0. So we can have x plus 1 is equal to 0. So that transposing positive 1 is going to be negative 1. And then x plus 3 is equal to 0. X is going to be negative 3. So these are our two values of x. So for number 19, solving for x here, we have another factoring. So let's see, we can have 1 times 8, 2 times 4, and that's it. So let's see here, we have x plus something and minus something because the 8 here has a negative sign. So we see that 2 is greater. 2 is positive. So we assign the plus sign on the greater number. So x plus 4. And then the other one is going to be 2. So we have x plus 4 and x minus 2. So we have our values. X is going to become negative 4. And x is going to become positive 2. Okay, so for number 20, we have 2x squared minus 7x plus 3. We can notice that because of the 2 here, this is in the form x squared plus bx plus c. So when we see that the a is not equal to 1, or it has a numerical coefficient other than 1, we can use the AC method. So again, the AC method is a shortcut. Um, there are parts of it that are not mathematically correct on its own. That's why you need to indicate that it is the AC method so that your paper will not be deducted points. So the AC method is going to be like this. You multiply 2 to 3 to get 6 because this is A and this is C. Now we are supposed to factor this as usual. So we know that um, because this is positive for the product, that these signs have to be the same. And since the sum is negative, then we need to use negative sign. So x minus something times x minus something. Now, the factors we can use are 1 times 6 and 2 times 3. So in achieving this negative 7, we need a negative 1 and a negative 6. So this is our factor for the AC method. But remember that we still have to reverse the AC method. We have to reverse the A. So we have to divide it by 2. So in reversing this AC method, we need to divide this part. So 6 divided by 2 is 3. And then for this one, x is equal to 1 half. If it cannot be fully divided, we need to return 2 to the other side, which is 2x minus 1. So the reason why I put AC here is because these are just the steps for the shortcut. The actual mathematical computation should look something like this. And if you're wondering, what is the purpose of this form before we return it, if you equate it to 0, then this will actually give you the roots of it or the solution. So x is going to equal to um, positive 3 from here, no, positive 6 over 2 or positive 3, and positive 1 half. So if you equate this one to 0, you're also going to get the same answer. So for number 21, let's expand this expression. So we can use a distributive property or the extension of the FOIL method here. So x times x squared is x cubed, x times cx is cx cubed, and x times 4 is 4x. Similarly, negative 2 times x squared is negative 2x squared. This will be negative 6x, and then this will be negative 8. So we can align them like this so that it's easier to add. So after adding this, we have x cubed plus x squared minus 2x plus 8. So basically, we just added the like term. So for number 22, let's have the equation of a parabola. So in vertex form, we have y is equal to 8 times the value of x minus h plus k. So here, x and y are values from a point xy which lies on the parabola. So here, let's draw it. If this is our parabola, xy can be any point, can be here, 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 anywhere, as long as it satisfies the parabola. So a is a coefficient that tells us which direction the parabola opens. So if a is positive, it's going to open upwards. If a is negative, it's going to open downwards. Lastly, we have h and k, which are the coordinates of the vertex, the minimum or the maximum of the graph at vertex, vertex hk. So here, we find h and k here. These parts will tell us the vertex or the center of the parabola. And by extension, it also tells us where the parabola is symmetric. So let's have some examples. So graph y is equal to x minus 2 squared minus 4. So from here, we can already see that this is our h and this is our k. Be careful with the signs since beside h there's supposed to be a negative sign and beside k there's supposed to be a positive sign. So in graphing this, we have vertex at 2, negative 4. So let's draw our Cartesian coordinate system. We go to 2 here and then negative 4. 1, 2, 1, 2, 3, 4. And now we have to check where the x-intercepts are. So recall that the x-intercept is where it touches the x-axis. So when it touches the x-axis, the value of y is equal to 0. So that's why we have 0 here. So what we need to do is to solve for x this time. Transpose negative 4 to the other side. So we have 4 is equal to the square of x minus 2. So apply the square root on both sides. We have x minus 2 is equal to positive or negative 2. Transpose this one to the other side. So x is equal to 2 plus 2 plus or minus 2. So when you have 2 plus or minus 2, you need to evaluate it as 2 plus 2 and 2 minus 2. So that's how we get 0 and positive 4. So basically what this means is on our x-axis, we have one point here at 0. So this is going to be 0, 0. And then we have another at 4. So 0, 1, 2, 3, 4. at 4, 0. So these are our points on the parabola. So we can also see that A is 1. It's positive 1, so it opens upwards. So we just connect the lines in making our parabola. So here is what it looks like when graphed on a graphing software. So again, this is the vertex, and these are the x-intercepts. So for number 23, what is the vertex of this? So we can see here, it's not in the vertex form, but we can put it in the vertex form if we need to. So we can see here that there is the x squared part here. What we need to do is group this, all the parts with x, and we have to turn it into a square. So this method is called completing the square. So basically what we're doing is x squared minus 6. We're going to turn it into something we can square so that we can write it as y is equal to 8 times x minus h plus squared plus k. So this is what we need to do here. Um, x squared minus 6x. So in order to turn it into a perfect square, we need to divide the middle. So recall that x plus y squared is equal to x squared plus 2xy plus y squared. So if we're going to reverse the process, we have multiplying by 2 becomes dividing by 2. So 6 divided by 2 is equal to 3. And then we have to use this 3 to find y squared. So 3 squared is going to equal to 9. So that's why we added 9 here. So this makes x squared minus 6x plus 9 into x minus 3 squared. So in order to keep things balanced, whatever we add here has to be subtracted. So if we add 9, we have to subtract 9 outside. So that's going to be y is equal to the square of x minus 3 plus 5 minus 9, which is negative 4. So in looking for our vertex, we have negative h, which is here, and then plus k. So plus k includes this negative sign. So that's why our vertex is 3, negative 4. So for number 24, we'll be encountering some other special products that are less common but can still appear on tests. So we have the cube of a binomial, which is basically having something like x plus y or x plus 2 raised to 3. We can also have it for x minus y, where it changes only in the signs, here and here. For the sum and difference of two cubes, we have a cubed plus b cubed, or a cubed minus b cubed. It can be rewritten as this one. So if you want to remember this, just make sure that just make sure that you know where the minus sign goes. And also you know that this is not 2ab, it's only ab. So let's proceed. So number 24, let's simplify this rational expression. So we have x cubed minus 8 and x minus 2. We know that x cubed is the cube root of x cubed is x, and the cube root of 8 is 2. So our goal is to eliminate x minus 2. And then our final answer will be whatever is left. So let's proceed. So following the pattern for our special product, we have x cubed minus 2 cubed is equal to x minus 2 times the value of x squared plus 2x plus 2 squared. So we can rewrite this as 4. So we know that this will be cancelled and we'll only be left with x squared plus 2x plus 4. So that's the end of number 24. So for set 4, we have exponentials and trigonometry. So we're going to be tackling rational expressions, exponential and logarithmic functions, inverse of a function, trigonometric functions, and the unit circle, radians, and degrees. So let's simplify this expression. So it's similar to the one we had in number 24. 3x squared minus 12x over 6x. In this case, we need to factor something that is in all of these. So note, you cannot just cancel directly here or here because there is a negative sign. So these are considered two terms. So this is how we can simplify it. We can factor out 3x from 3x squared minus 12x since 3 and 12 are both divisible by 3 and x squared and x both have an x in them. So for 6x, this can be written as 3x times 2. So in cancelling these parts, we are left with x minus 4 over 2. So if you're familiar with Pascal's triangle, we can use it for binomial expansion. So recall earlier that we had this pattern in our cube of a binomial. Namely, it is x cubed plus 3x squared y plus 3xy squared plus y cubed. So an easy way to remember this, or rather a general way to remember this for any binomial expansion with an exponent that is a whole number, a positive whole number, you can use this Pascal's triangle. So you notice that it starts with this, with 3 ones at the top, and then everything else is just going to be a sum of the numbers surrounding it. So it keeps going down. You'll notice here that it is 1, 3, 3, 1, just like the pattern on Pascal's triangle. And then the pattern for this is always going to be the first variable is going to start with the highest degree, like 3, 2, 1, 0. And then the second variable is going to be 0, 1, 2, 3. So this is where these exponents come from. So x cubed, x squared, just x, and no x. And then here we have no y, 1y, y squared, and y cubed. So you can follow this pattern even for larger ones like 2x minus 3y raised to 5. So if you have something on your paper like find the third term of this, you just have to continue it here. And then you find the third term. So you don't need to compute the whole thing. You just have 10 times 3, oh sorry, 5, 4, 3. And then this one is going to be 2. 80 times, so negative 240 x cubed y squared. So just a fun fact. But for this item, we'll be focusing more on this given. So for method 1, if you're not familiar with the Pascal's triangle, you can just use the distributive property. So we have 2x minus 1 times 2x minus 1 squared. So basically, you just split this. Use the special product on this one, and then you have 2x minus 1 times 4x squared minus 4x plus 1. So this is the final answer if you do it like this in distributive property. But personally, I think it's shorter to use the binomial expansion. So you have to find this 1331, and then you just get it from here. So we have the cube of 2x, which is 8x cubed, three times 2x squared times b, plus 3 times the square of, sorry, 3 times 2x times the square of negative 1 plus the cube of negative 1. So here's the full solution to that, and you can see that we arrived at the same answer. So for number 27, we have finding the inverse function of f of x is equal to 2 over x plus 3. So when we have an inverse function, we have y and x swapping places. And then we have to solve for y again. So I swapped the places of x and y here, and now we're going to solve for y again. So first of all, we multiply both sides by y plus 3. And then we divide both sides by x. Lastly, I transpose positive 3 to the other side. And it becomes y is equal to 2 over x minus 3. So to write the final answer for this, you can write f raised to negative 1 of x is equal to 2 over x minus 3. So speaking of inverses, we have logarithms and exponents as inverse functions of each other. We're already familiar with the notation 3 squared is equal to 9. So we can also rewrite this as logarithm of 9 with a base of 3 is equal to 2. Similarly, we can rewrite it as b raised to x equals y, or logarithm of y with the base b is equal to x. So let's solve for x here. So logarithm of x to the base 4 is equal to 3 is basically asking us what is the number that results from raising 4 to the power of 3. So this is going to be 4 times 4, 16. 16 times 4 is 64. So x is equal to 64. So for number 29, in order to solve for x, we need to rewrite 16 in the same base as it. So as we can see here, 2 raised to x. So 16, we have to rewrite that as something that is in base 2. So using the powers of 2, we have 2, 4, 8, 16. That's 4. Now there's a property of logarithms that we can use here. So we can get the logarithms of both sides. And from here, we can conclude that x is equal to 4. Or we can just do the shortcut where we see that 2 raised to x is equal to 2 raised to 4. So anything that is not, anything that is the same here will be equal here. So for number 31 and 32, let's have set 4, exponentials and trigonometry. So on the left side of the screen, we have SOHCAHTOA, which is sine for the opposite over hypotenuse, cosine for the adjacent over hypotenuse, and tangent for the opposite over adjacent. So we'll be using these a lot, and since we're practicing for um, calculus 1, we're going to train ourselves to not use a calculator. So um, the next examples will be using these 30, 60, 90, and 45, 45, 90 triangles. So basically, we'll be applying this in this example. So let's evaluate sine of 30 degrees and cosine of 60 degrees. So sine of 30 degrees is going to be so opposite over hypotenuse. We know that there are measurements for these triangles. So we know that it is going to be 1, 2, and square root of 3. So the first one we have is sine of 30. So sine of 30 is going to be opposite over hypotenuse. So that's going to be 1/2 plus the cosine of 60. So the cosine of 60 is going to be SOHCAHTOA. So ka is going to be adjacent over hypotenuse. So this is also going to be 1/2. So 1/2 plus 1/2 is equal to 1. So evaluating this, you can see that it is equal to 1. So as a general rule, 30 and 60 are complementary angles. So if you get the sine and cosine pair of complementary angles, you're going to get 1. So if you want more examples of this, feel free to check out the full version of this course available in the description. For numbers 31 and 32, we'll be using the unit circle. So the unit circle is basically the tool we use for converting degrees to radians, as well as evaluating some values of sine, cosine, and even tangent. So we know that this is 0 degrees and this is 180 degrees. So we can say that 180 degrees is equal to 1 pi, or simply pi. So when we convert something into degrees or radians, we can use pi over 180 or 180 over pi. Additionally, the other values here also correspond to the 30, 60, 90, and the 45, 45, 90 triangles. So this one's going to be 30 degrees, 45 degrees, 60 degrees, 90 degrees, and so on. So in the unit triangle, remember that their values start from the right, going on to the first quadrant, the second quadrant, third quadrant, and then the fourth quadrant. So to apply what we've used earlier, so evaluate sine 30 degrees. So the sine of 30 degrees would be around here. So 30 degrees. And then the sine of that would be opposite over hypotenuse. So for cosine of 60 degrees, if we had this for sine, then our cosine earlier would be here. So you can see that they're actually a similar shape here on the unit circle. So that's another hint that it is close to the situation earlier. So remember, in using the unit circle, generally you have the degree or the radian that you want to use as the angle, and then you have to draw a line straight down until the x-axis, or straight up in the case that you are starting from the bottom. And then the angle will be here. So this is what this illustration is for. So let's use the unit circle in here. So convert 120 degrees into radians. So as mentioned earlier, 180 degrees is equal to 1 pi radians. So we want to cancel the degrees, so you put the degrees on the bottom and the radians on the top. 120 divided by 180 is 2/3. So we multiply this 2/3 to pi, and then we copy the radian sign. So 120 degrees is equal to 2 pi thirds radians. So for the next one, solve 2 sine x is equal to 1 for all angles between 0 and 180 exclusive. So we need to see here, solving 2 sine x, we have sine x is equal to 1/2. So seeing 1/2 here, we know that this is going to be sine, this is going to be the opposite, and this is going to be the hypotenuse. So we know that this matches 30 degrees, right? From our example earlier. So we have to check if there are other angles that fall within this range. So 0 to 180 degrees. So in using our unit circle, we have here. So our value is going to be 1/2, right? So this is positive 1/2. Recall from our set 1 that a positive number can come from multiplying two positive or two negative numbers. So here we have the x is positive and here the x is positive. X is negative and x is negative here. We have positive y on top and the negative y on the bottom. So as you can see, we cannot have this and this quadrant because we need both positive and both negative. And we also cannot have this one here. We cannot use this one because the problem specifies only between 0 and 180. So for this question, the only x that we can have here is x is equal to 30 degrees. So for set number 5, we'll have some pre-calculus foundations. So Under precalculus, we have sequences and series, exponential and logarithmic functions, introduction to limits, function continuity, and the average rate of change. So this will be the last set in this preview video. So for numbers 33 to 34, we have sequences and series. First is arithmetic and then geometric. So basically, the difference of arithmetic and geometric is that arithmetic has a common difference, or there is something being added or subtracted every term. For geometric, there is r, which is a common ratio, something that is being multiplied every term. Take note that d and r can be positive or negative. So the things that all these formulas have in common is they have a sub 1 and a sub n. So a sub 1 is the first term in the sequence, and a sub n is the nth term, or in some cases, the last term. It is the term that you want to solve for. And lastly, n is the number of terms. So let's use some of these formulas in the following items. So number 33. Determine the fifth term of a sub n. So generally, if the formula is already given, all you have to do is to substitute. So a sub 5 is going to equal to 3 times 5, which is 15, plus 2, which is 17. Now, in the case that it is not given as an equation, you have to identify it yourself. So let's determine the sum of the sequence 2, 4, 8, 16, and 32. So we can see here that 2 is going to be a sub 1. 32 is going to be a sub 5. And there are 5 in the given, so that's going to be n is equal to 5. Now, the thing that we have to find here is if it's a difference or a ratio. So let's see here. 2 plus 2 is 4, but 4 plus 2 is not equal to 8. So it might not be a difference. Let's try multiplying. 2 times 2 is equal to 4, 4 times 2 is equal to 8, 8 times 2 is equal to 16, and 16 times 2 is equal to 32. So if it's consistent here, we can determine that the ratio is positive 2. So let's apply the formula. The sum of this sequence is going to be a sub 1, which is 2, times r, which is 2 raised to the number 5, minus 1 all over r minus 1, so which is 2 minus 1. So simplifying this is going to be 2. This one is going to be 32 minus 1, so it's going to be 31. And then this one at the bottom, 2 minus 1, is just going to be 1. So our answer here is going to be 62. So you can double check it by adding these manually and you should get the same answer. So for number 35, we have function composition. So evaluate f of g of 2. So one thing that you need to know here is that if you see this is function composition. You can rewrite it as f of g of 2. So the steps you can take here are to solve g of 2 first, and then whatever you get from g of 2 will be your input for f. So let's see. We have f of g of 2. So first we have to start with 2 squared here, which is 4. So after that, we have to solve for f of 4. So that's going to be 2 times 4 plus 3. 8 plus 3 is going to be 11. So our answer for this question is going to be 11. So for number 36, we have to rewrite f of x equals the absolute value of x minus 2 as a piecewise function. So let's consider this example. We have -5. So -5 and 5 are both different numbers, but if we put them under the absolute value function, we get the same result, which is 5. So for any number, we have this. If it's a positive number, then the absolute value of it is just going to be itself. So if x is positive, and if it's already a negative number, like -5, it's going to be negative of itself if it is a negative number. Now, using our knowledge of functions, we can just replace x with x minus 2. So it's going to look something like this. So x minus 2, it stays the same if it is positive. It gets negated, so 2 minus x, if it is negative. And lastly, the last consideration we need for our piecewise function is to make sure that it covers everything. So earlier, we checked if it is positive or negative. So we can see here that we were not able to take into consideration 0. So absolute value of 0 is still 0. So it's still itself. So I'm going to include it here in x is greater than 0. So I'm going to include it as greater than or equal to 0 to make sure that the piecewise function is complete. So now for number 37, let's check at what point is x squared minus 1 all over x minus 1 discontinuous. So discontinuity is defined by a function not having a certain value at a certain x value. So here, we obviously know that x minus 1 cannot be 0. So x cannot be positive 1. So the point is discontinuous at x is equal to 1. So if you're curious what this looks like, it looks like this. We are left with x plus 1 after we cancel x minus 1 in the numerator and the denominator. So x plus 1 looks like this on the Cartesian coordinate system. X plus 1 here. At the point of x equals 1, there is a hole, and then everything else is continuous. So when we graph this, there is a hole here because it is said that x cannot be equal to 1. So the hole represents the function not continuing at that specific point. So there are different kinds of discontinuities, some of them being the removable discontinuity that was showed earlier, the jump discontinuity, which is common with with piecewise functions, and the infinite discontinuity, which often happens in rational functions. So for numbers 38 and 39, let's discuss limits. Limits are a crucial concept in calculus, so let's make sense of this image. We can read this as the limit of f of x as x approaches a is equal to L. So this green part here, f of x, is the function. It is what we are operating with. It is where we will put the x value, and then we are expecting to find a y value. So here, x approaches a. As you approach a along the x-axis, a is a value that we are using for x. So for example, as x approaches 2, we may be interested in the values like 5, 4, 3, 2.5, 2.1, 2.01, 2.001, etc. So we're not actually using the value itself, like x is equal to 2. We're using things that are near it. So as we approach or get nearer the a that we have decided, we are getting closer to this y value based on the function. So for number 38, we're using the value x approaches 3 for this function. So if this is our function and we use f of 3, we're going to get undefined because 3 minus 3 in the denominator will make it 0. And actually, 3 squared is going to be 9. So 9 minus 9 is going to be 0 over 0. So it's also going to be an error. So the reason we cannot directly substitute 3 into f of x is because of that. But we can use values that are approaching 3, such as 2.999 or 3.000000, and so on. So the closer we get to 3, but not actually using it, is the closer we'll get to capital L, which is the limit. So let's evaluate it. We can do this by factoring the numerator, going to be x plus 3 and x minus 3. So we have x plus 3 being the function that we are getting the limit of. So in evaluating this, now we can use f of 3 here because the domain no longer um, applies for this one. So we have 3 plus 3 is equal to 6. Take note that the function will not actually equal 6. It will just approach 6 since that is how limits work. But this is a good enough answer. We have the limit of this is going to equal 6. For number 39, we'll use the average rate of change, which is measured between point A and point B. So basically, this formula is slope. So recall earlier how a slope is y minus y sub 0 and x minus x sub 0. So this time, our y is going to be the result, and then the x is going to be the input. So using this concept from earlier, with the result and input, we can measure the average rate of change instead of just the position on the graph. So let's proceed to number 39. So find the average rate of change of f of x is equal to x squared from x equals 1 to x equals 4. So based on our image, B is the one that is on the right of A. So that means this one on the graph will be B, and then this one will be A. So we have f of B as f of 4 minus f of A, which is f of 1, all over 4 minus 1. So this one, f of 4 is going to be 4 squared, 16. F of 1 is going to be just 1. And 4 minus 1 is going to be 3. So we have 15 over 3, or 5. So for number 40, if a particle moves such that its position at time t is defined by function s of t, find the average velocity from t equals 1 to t equals 3. So basically, we are measuring the position. So velocity is the change in position at these times. So 3 is going to be b, and a is going to be 1. So we're going to have s of 3 minus s of 1 all over 3 minus 1. So inserting 3 into this, we have 3 times 3 squared minus 2 times 3 minus the value of s of 1, which is 3 times 1 squared minus 2 times 1. So when doing that, we need to consider these. Be wary of the negative sign. You don't necessarily have to distribute it. You can just simplify whatever is inside first. So this is going to be 3 times 3 times 3, 27, minus 6. That's going to be 21. 3 minus 2 is going to be 1. And then this one is just going to be 2. So we have 21 minus 1 over 2. So that's going to be 20 over 2. So according to our computations, the average velocity is going to be 10. So if there was a unit given, for example, t is equal to 1 second and the position is stated to be in meters, then we have to use the unit meters per second. So that marks the end of sets 1 to 5 of the algebra review. If you found this useful, I hope you'll be excited for the geometry set. So this challenge set is full of word problems where we tackle angle theorems, perimeter and area, surface area and volume, square cube law, conic sections, and more. Coming on August 19. If you found the contents of this review useful, I highly recommend availing the full course. For only 199 pesos, gain access to an additional 150 items, including 6 sets of Google Slide downloads, 6 sets of printable cheat sheets, access to Google Classroom for one account, and 35 items of a mock test on Google Forms to simulate learning on a real online classroom environment. So what are you waiting for? Avail now. This has been Killjovier Creatives, and thank you for watching.